Welcome back. In the last episode, you built and pushed a container image, and today we're going to actually run it on a real Kubernetes cluster. The plan is refreshingly simple. One deployment to run your pods, one service to expose them, two small YAML files, and a single kubectl apply. By the end, you'll have a working app on Kubernetes and a clear mental model you can reuse for every project after this. So, before we touch any YAML, let's be honest about why we're even doing this. With Docker Run, you've got one container on one server, but the moment you need 5 copies behind a load balancer, automatic restarts when something crashes, or rolling updates with no downtime, you're suddenly babysitting infrastructure by hand. Kubernetes flips that around. You declare the desired state. Say 3 copies of your image alive and exposed, and the cluster makes it true and keeps it true. You declare Kubernetes maintains. To make that promise real, you only need 3 objects. A pod is one running instance of your container, basically the Kubernetes wrapper, around what you'd get from Docker Run. A deployment sits above it and keeps npods alive, handling restarts and rolling updates for you. And a service gives that group of pods one stable address, so clients don't care which pod answers. Deployment manages pods, service fronts them. That really is 90% of shipping an app. Before we write any YAML, we need somewhere to apply it. So step 1 is getting a cluster and the kubectl CLI on your machine. For learning, just run something local. Kind or minikube will spin up a real Kubernetes API in a minute or 2. In production, you'd reach for EKS, GKE, or AKS, but the workflow is identical. Once kubectl get nodes shows a node in ready state, you're set. Kubectl is now talking to a live cluster. With kubectl ready, let's write the first of our 2 small YAML files. The deployment. This is where you declare the desired state. I want 3 pods, each running the image you pushed back in episode 3, listening on port 3000. Notice the selector and the template labels both say app, my app. That's how the deployment knows which pods it owns. Save it as deployment.yaml, and Kubernetes will take care of keeping those 3 replicas alive. Now comes the satisfying part. One command, kubectl apply fdeployment.yaml, hands that file to the cluster, and Kubernetes does the rest. Pulls your image from the registry, schedules the pods, and starts them. A quick kubectl get pods confirms it. 3 replicas, all reading 1/1, all running. And here's the mantra in action. You declared 3, so Kubernetes will keep 3 alive, even if one crashes. But your pods are running on shifting IPs. Every restart, every reschedule, the address changes. That's where the service comes in. It gives your pods one stable front door and load balances traffic across them. The selector app, my app, is the glue. It finds every pod carrying that label and wires them up. Port 80 is what the outside world hits. Target port 3000 is where your container actually listens. 2 small files, one consistent pattern. And here's the magic of that wiring. The service doesn't care about pod IPs at all. It just looks for any pod carrying the label app, my app, and routes to it. Spin up 3 pods. It balances across 3. Scale to 10. It balances across 10 automatically. If you've used Compose's service DNS, this is the same idea, just leveled up for a real cluster. So let's zoom out and trace the whole journey in one breath. Your image sits in the registry. You run kubectl apply to send the YAML. Kubernetes pulls the image and runs your pods. The service gives them one stable address with load balancing, and users finally hit your app. Dockerize, compose, push, deploy. That's the path from your laptop to a real cluster. Now that the path is clear, let's talk about what you actually get for free once your app is running on the cluster. If a pod crashes, Kubernetes restarts it. No pager, no panic. Need more capacity? One kubectl scale command, and you're at 10 replicas. Push a new image, and you get a rolling update with 0 downtime and an easy rollback, while the scheduler quietly spreads pods across your machines. You declared the desired state once. The cluster keeps it true forever. With all that power running in the background, you'll still spend most of your day in just a handful of kubectl commands. Start with the big three. Get pods to see what's running, logs to peek at a pod's output, and describe pod when something refuses to start. That's almost always where the answer hides. Beyond that, scale changes your replica count on the fly, rollout restart cycles things after a config change, and delete F tiers down exactly what you applied. 6 commands, and you're operating a cluster. Now, before you hit apply, let's flag the traps that catch almost everyone. Image pullback off usually means a typo in the image name or a private registry with no pull secret. Using the .latest tag feels convenient, but it makes rollouts and rollbacks pure guesswork. Pin a real version. A service whose selector doesn't match your pod labels will quietly route traffic nowhere, and skipping resource requests and limits lets one greedy pod starve the whole node. Now, if any of that felt intimidating, here's the reassuring part. Everything you already know from Compose carries straight over. A Compose service becomes a deployment managing pods. The port section becomes a service. Depends on and DNS by name become service discovery by label. And Compose up and down become kubectl apply and delete. Same mental model. Kubernetes just adds the scale and resilience on top. So let's pull the whole journey together in one quick recap. A pod is a single instance, a deployment keeps the number you asked for alive, and a service gives them one stable address. Your deployment, YAML points at the image you already pushed to the registry, one kubectl apply, F hands it to the cluster, and Kubernetes pulls and runs the pods for you. The service then finds those pods by label, not IP, and load balances across them. And from that moment on, Kubernetes self-heals, scales, and rolls out updates on your behalf. And if you only remember one image from this whole episode, make it this one. Kubernetes is a ship's crew for your containers. With Docker run, you're holding one container by the hand. If it falls over, you pick it back up. With Kubernetes, you just tell the captain the goal. Keep 3 of these running. Expose them to the world, and the crew handles the rest. You declare the desired state, the cluster maintains it. And take a second to appreciate how far you've come. You started by dockerizing a single app, then wired up multiple containers locally with Compose, pushed your image to a registry so it could travel, and now you've got it running on a real cluster. That's the full path, from one container on your laptop to a scaling deployment. Next, we'll make it production grade, health checks, secrets, and resource limits. Before we push into production topics, it's worth seeing how this episode plugs into the rest of the channel. The image K8's just pulled, that came from the registry work in episode 3. The pods you defined in YAML connect straight to the infra series on pod internals and on RBA and least privilege. And that service you wrote ties into the networking deep dive on load balancers you can run on Kubernetes now. Securing and scaling it is the next level. So if you want to go deeper, there are 2 clear paths. On the Infra Explain side, you've got free written guides. What Kubernetes really is, how pods and containers fit together, security basics, and the CI/CD and infrastructure as code pieces that sit around your cluster. And when you're ready to harden what you just deployed, RBAC, secrets, network policies, resource limits, the Kubernetes hardening course at Dargslan.com courses walks you through it end to end. Before we wrap up, I want to hear from you. Have you actually deployed something to Kubernetes yet? Was it a local kind or minikube cluster, or did you jump straight into a managed one on a cloud provider? And honestly, what tripped you up first? An image pullback off, getting a service to expose your pod, or just wrestling with the YAML? Drop it in the comments. That's how we shape the next episodes. And that's the journey. From a local image on your laptop to a deployment and service humming along in a real cluster. Next stop is making it production ready, liveness and readiness probes, proper secrets handling, and locking things down. That's exactly what the Kubernetes hardening course over at Dargslan.com covers, so hit subscribe and I'll see you in the next one. Thanks for watching.